This diagram shows the action of a small-scale underwater explosion. At the instant of detonation, an enormous initial pressure, estimated to be in the order of 100,000 atmospheres, is produced. This pressure dispatches a shock wave and imparts a large momentum to the water. Because of the large momentum, a gas globe, produced by products of the explosion, expands radially outward. It travels beyond the point at which its internal pressure equals the hydrostatic head of the surrounding water. Eventually, however, the hydrostatic pressure brings the expansion to a halt. And since the interior of the globe is at a low pressure, a contraction is started. At the point of collapse, another shock wave will be sent on its way, and the cycle of expansion and contraction will be repeated until all the energy of motion is dissipated. Here, a number 8 electric blasting cap is exploded 12 inches below the water surface. The total depth of the water is 6 feet. Note that each succeeding pulse decreases in amplitude and duration. The depth below the surface is increased to 24 inches. The object at the extreme right is the illuminating lamp. You may observe a cavitational fog coming from the lamp. The same explosion at 36 inches below the surface. The gas globe formed in this explosion will reach a maximum diameter of 11 inches. The time required for the first pulsation was 24 thousandths of a second. The charge is placed 36 inches below the water's surface, 30 inches from the back wall, and 24 inches from the side wall. The rigid surface of the nearby wall attracts the gas globe. The charge is moved to 18 inches from the side wall. Note the motion of the globe towards the side wall. The same charge 12 inches from the side wall. It will be noted that the gas globe starts its movement toward the side wall only after the completion of the first pulse. The charge is now 6 inches from the side wall. The vibrations of the lucite lamp face are caught in slow motion. Again, you may observe a cavitational fog which appears to come from the lamp face. The charge is now moved to within 3 inches of the wall. Observe how the gas globe beats upon the wall. The number 8 cap in contact with the side wall. The gas globe formed against the wall has less than half the volume of the globe formed away from the wall. These sequences have shown that the second and succeeding pulses moved toward the side wall. Later pictures will show that the gas globe moves toward any rigid surface. Here, a 4-foot square, flat-bottomed float drawing 1 inch of water serves as a boat. A number 8 detonator cap is placed 12 inches under the boat. The globe moves slowly downward, away from the boat. We have previously seen, under similar conditions, but without the boat, that the gas globe also moved downward. The charge is placed 6 inches under the boat. The globe moves toward the boat. This parallels the action previously observed when a charge was placed 6 inches from a vertical wall. In contact with the boat, The charge is the dark object lying horizontally just above the center of the picture. Here, as in contact with the vertical wall, the gas globe has less than half the volume of the globe formed away from the boat. The water is 36 inches deep. The charge is in contact with the bottom. Midway between the bottom and the water surface, the gas globe moves toward the bottom. The cap placed 3 inches under the surface. Observe that the gas globe travels 33 inches to the bottom. 1 inch under the water surface and 35 inches above the bottom. In shallow water, the bottom of a boat and the channel bottom present relatively rigid adjacent surfaces. The cap is 23 inches below the boat and 10 1/2 inches above the bottom. The gas globe is attracted by the nearest and most rigid surface. A charge twice as heavy is fired with the same setup. A still larger charge, 1/2 ounce of tetrol. This is studied by a number 8 cap midway between 2 vertical steel plates, 12 inches square, 1/2 inch thick, 18 inches apart. When the plates are 12 inches apart, the globe divides and attacks both plates. Firing between the plates 6 inches apart. Note the vibration of the plates in opposite phase. These photographs have been presented as studies of the very rapid action which takes place in underwater explosions. While the explosive actions shown here were violent, it must be remembered that they have been explosions of a very small scale. The relationship between the action of the small charges used in these experiments and the explosions of mines and torpedoes is not known. However, it is hoped that studies such as these will aid our understanding of the explosive action on the hull of a ship.